Hello and welcome to this webinar. Thanks for giving us the next half hour. My name is Miroslav and I'm here with my colleague Igor from Kroz, and between us we run quantum safe readiness assessments. I guide the process and Igor is the one who actually reads the cryptography. We'll take 2 minutes on who we are and then get straight into it. So my name is Miroslav. I'm a software tools architecture integration consultant at Kroz with company from 2013, working with various complex and complicated systems with various roles and industries. In the last few years, my focus has been quantum safe and quantum safety in general, and also AI-enabled systems. Igor?
And my name is Igor Sokac. I'm with Kroz for the last 24 years. I've fulfilled various roles, first in the systems management, then in project management, and lately, or I would say in the last 10 years, I've been dealing with IT security from various standpoints. Quantum safe is one of those important pivotal terms that are important, and we are going to dive into that today.
Great. So let's start right into it.
Yes. So somewhere right now, someone is probably copying your encrypted traffic, and that's the traffic they actually can't read. So I'm talking about VPN sessions, I'm talking about your database backups, maybe some health records, and they are just storing it. They can't, as I said, they can't open it today, but they are betting on the fact that quantum computing is advancing pretty rapidly, and that that encrypted information might be decrypted within the next several years.
Yeah. So this is actually the uncomfortable part of the story, because the data you send today, create and encrypt today over the public networks, it's probably already somewhere in some of those archives. So the clock on becoming quantum safe doesn't start when quantum computers arrived. It already started the day you encrypted something that has to stay secret for a decade. And now, when you think about it, you're probably in one of 4 camps on this topic. You either never thought about this issue, you have this issue on this radar, but you don't have a plan of action. You already got a plan of action and you maybe started with some activities, and or you are in the, I would say, most advanced camp. You already started migration on the post-quantum cryptography. If you're in a camp 2, meaning that this issue is on your radar, but you have no plan, today's session is exactly built for you, and we will try to explain to you what Kroz can offer to help you get the plan. So, I'm your guide, and we want to show you today 3 things. First thing is we want to show you how our assessment process looks like. It's divided into 5 phases. We will go through each of them to show you that this is a comprehensive assessment, not something like a high school science project. Topic number 2 that we want to discuss, we want to talk to you about the questions of urgency. And for that, we will actually role play some scenarios with some questions and some answers, so that hopefully some of you can identify in some or all of those questions and answers, so that you can gauge the urgency for your own organizations. And point number 3, we want to actually show you an example of a real scan report that we prepared, so that you can see what are the key artifacts and what are the key findings that we highlight and explain and put on a map for you.
Okay, so let's jump to the assessment.
Yes.
Okay, so Miroslav, can you? So this looks as a normal assessment without any differences from other types of assessment. Can you please give us some details?
Yes, I can. So as Igor already said, so pretty standard 5 phases from kickoff, workshops, actually performing some scans, creating a report, and then in the end, some presentation to the stakeholders. But what's important and what I think really differentiates Cross and us from other similar assessments that are already on the market is the fact that Cross has spent last 20 years actually building and implementing some of those complex systems that rely on the cryptography that is currently under the attack. And we, during this assessment, in this part of second part where we do the workshops with you, we are the ones that want to say what parts of the system needs to get scanned. Because in our experience, what gets scanned, it gets scanned, the most proud, the most cleaned up resources, the most cleaned up repositories, codes. We actually want to tackle the repositories that are maybe not so tidy, not so clear, but we want to bring exactly those kind of findings and those kind of information under the spotlight so that there is a real picture of how the quantum or cryptography landscape looks like.
Yes, we have been working, as you said, on enterprise systems, so large enterprise systems for quite some time, and we have seen the security develop and basically grow. So from the times that you were happy to have username and password, to this time of zero trust and multi-factor authentication and quantum safe, a lot of things had passed and changed, and we've been there in that process. So we made some mistakes, we learned from them. We have developed our own practices and our own way of thinking and working and our frameworks. So this assessment basically reflects those experiences.
Yes, exactly. And let's dive right into it now. So in this kickoff one, where we start. So the first thing, and it all starts with one document. This document is actually a questionnaire that we sent during the kickoff phase, even before we start the workshops, that guides the principle and guides the process, because it enables you, the client, to know what kind of questions we will be asking on the workshop, so that you can prepare yourself and find the relevant key stakeholders, find the relevant information within your organization, because experience tells us that there isn't currently, one stop, one person, one dedicated team that is responsible for such questions and is able to answer all the questions that are in the questionnaire. So we want to give you a heads up. And then in the workshop phase, we go over this questionnaire, we fill in the missing gaps regarding the questionnaire, and then we talk about, as I already said, what kind of systems and what repositories needs to get scanned during the phase 3, and then so on. Igor, maybe we can show now how this questionnaire looks like. So on the screen here, this is the table of contents for the questionnaire. We will not go through all the questions that are there, because there is quite a lot of them. What we will do, we will role play 3 questions, as I already said in the intro, on an example of a mock
company,
telecom. So maybe Igor, before we dive right into questions, maybe you can give some background on the client.
Okay, so imagine that you are a mid-sized telecom. That means a couple of million of users with mobile and broadband and a lot of people basically depending on you. And this is the typical, let's say, customer. When we are talking about telecoms here, this is not only for telecoms, of course. the assessment we are doing in various other types of companies, not only telecoms. So we are doing assessments in financial industry as well, energy sector as well, logistics, and so on.
Insurance,
insurance, yes, government companies. So, but this is what a typical customer might look like.
Yes.
So, I'll be talking from the position of C-level executive who is very interested into our findings and into our quantum safe readiness.
Yeah. So, and the questions that we selected, they kind of stem like into three categories. First one, we will talk about the critical infrastructure, longevity of the system, and the data age, so data shelf life. So first question, do you operate systems critical to large groups of people?
Yes, of course. Here the obvious answer is yes. So the infrastructure is critical to a large number of customers, ranging from ordinary private users to large companies, from emergency services to different enterprises that are exchanging the information via our networks.
Yeah, so obviously telecom selected here is kind of like a special case because all other industries also depend on them for their communication, and they sit actually on top of it. But what's important for our audience is that a single yes to this question, do you operate a critical infrastructure for large groups of people, basically puts you in something which our method calls an urgent adopter, because in the end it's not the question of how big you are, is the question of who gets hurt if something breaks on your side. And this ties nicely into our next question is, how long-lived the systems are within your organization that you are putting into production today or you put into production in previous years.
As you might imagine, large companies like telecoms cannot just rip and replace the systems they have within 1 or 2 years. Usually the lifespan of core systems, of core network systems, is much more. Also, other systems, satellite systems like CRM, for example, like identity and access management systems, like basically databases that are being an infrastructure for the applications we offer, they all tend to be with us for quite some time.
So basically, systems that your organization ships today will probably run once this quantum threat becomes real, and they need to be able to adopt to the cryptographic requirements, not just from today, but also in the future. And this, I believe, nicely ties also to the third question regarding the data shelf life. So basically asking you, if somebody decrypts the data that is flowing through your systems today, would that still be damaging to yourself, to your organization, or to your clients in like 10 or 20 years?
Yes, that's an interesting question, because when I think about that, usually there are some obvious data like personally identifiable information, like bank accounts, like passwords, like some critical business-related reports, data, patents, and things like that. But there's also much more. For example, if you are a telecom, the entire communication between people, between various parties, is going through your encrypted channels, through a VPN channels, through your WhatsApp messaging, through your whatever you have, whatever means of communication you have. So that's also important data. It might be interesting for somebody in 10 or 20 years. And I'm not talking here about just financial data. I'm talking about health data as well. I'm talking about military, about security. So there is a lot of information stored in that data, currently encrypted and safe, that might be damaging in the next 10 years.
This data is exactly something that this harvest now decrypt later
Yes.
targets. And now for the audience, let's just like pause for a second and try to answer these questions for yourself or for your organizations. You know, would your most sensitive data still be damaging if it were decrypted in 15 years, for example? And a lot of you, I believe, will say, I'm not sure. And sit with that answer, you know, because in our assessment, this answer, unsure, is in itself is a finding, because not knowing your data shelf life is also a gap. Organization should know the shelf life for all of its data that it produces. Even, you know, regulatory frameworks these days are pointing us in this direction, because it is important to know how long do we need to protect this data. That is a valuable input for our assessment. So this is the questionnaire, and based on this, as we said, we are selecting the target repositories that we want to scan to get the exact picture, because the real scan will tell you actually what you have in terms of like cryptographic assets within your organization, and the questionnaire actually answers what you think you have. So Igor, maybe you can show now how this scan looks like on one of the services that we created for this session.
So here is just an example, a small part of a system that was scanned. And that's important to say. So you can scan whatever you like, and usually you start with something small and obvious, and then go on and expand that to get the information from the system that from all systems that you basically have. And that being said, when you do that,
sorry to interrupt you. The thing that we see now on the screen, this is actually an example of a report our customers would get.
Yes. So it's not only about scan. We are currently doing the scan using a tool called IBM Quantum Safe Explorer. That's a great IBM tool for scanning the repositories in various programming languages. It does a great job in the scanning part, and also creates cryptographical bill of materials, and that's very important part of the findings that are being reported on later on. The next step is basically to make the interpretation of those results, and that's why you have reports like this one, which have the information for the executives, which are, let's say, simplified,
distilled down.
But yeah, distilled down maybe, and the most important findings are there. But there are also much detailed information about the exact lines of code where the cryptographic vulnerabilities exist. Also how critical things are, which parts of your system are endangered currently, which will be endangered quite soon, and which are quite safe.
Yeah. And what does the report for this application says?
Yes. So in the end, the scan has found several categories of vulnerabilities. As you can see on the screen, we put them in a report that's sort of traffic lights like. So you know what's critical, the red, you know what's okay, and you know what is somewhere in the middle, or what's yellow or orange. So basically we found out that there are vulnerable cryptographic algorithms that are still in use in our code, and we can find out and pinpoint where exactly they are. Also, we found out that there are some possible vulnerabilities with our symmetric encryption, but that's not so critical, because symmetric encryption is, as we know today, or as we know currently, not so much affected by the advances in the quantum computing world as other types of algorithms, so asymmetrical ones are. So that would probably mean that we would just need to increase the number of bits for our AES. Also, we found out that there are things that are okay. There were projects where quantum safe cryptography was already implemented. So usually a pilot projects, we are starting with that, and this is green. There is also one important, let's say, term that we can introduce here, and that's crypto agility.
So can you maybe explain a little bit, because you said semaphore like red, yellow, green, and now we have this like bluish, like cyan color, where you are actually point out that there is, if we want to exchange those algorithms within the code base, we need to do a swap as a rewrite of a software, and there is actually this, I believe, nicely ties into one of the questions that is also in the questionnaire, saying, asking how difficult it was to change the encryption codes last time that you had to do it. Based on our experience, this is always like a multi-person, multi-week project. And from what I'm understanding currently in the industry, there is a trend that this feedback loop and the activity of exchanging those keys needs to increase in cadence.
Yes, so crypto agility is all about efficiency. So depending on the code you have, we have seen everything. Let's just be frank. So from things like passwords hard coded into the source code, to cryptography calls directly into the main functions of the code, and those types of environments usually are not crypto agile. So it's not easy to implement, for example, more advanced crypto algorithm if you have such code. So if you have an more efficient code where all the cryptographic entities are basically part of configuration, not the logic or the source code, you are probably in a better position to swap them when they become vulnerable, or of course much before that.
So this is actually an activity, if I understand correctly, that is beneficial even if you are not on a path of exchanging the crypto algorithms now, because maybe you have a dependency on some other system that isn't able to speak quantum safe cryptography right now. But moving into a crypto agile manner of maintaining the cryptographic assets, it's a benefit in itself. Is this true or false?
Yes, yeah, that's true.
Okay,
that's true. And so here we have what Scan found.
Yeah.
It is interesting, but that's not enough. So
Yeah.
what we need to do, we need to make those information actionable. So we just need to have more steps in advance.
Let's dive into proposed moves based on what the scan found, because we can have a report, we now know where we stand, but this is just like wallpaper if we do not act on the findings. So here for this scenario, we outlined like five findings that would be interesting and that apply for this case that we are presenting today, but we deliberately took this example so that it will probably map to the vast majority of you listening to this webinar and this session. So the first, and we would say the most important actionable stuff that you can do is to prioritize fixes by the data shelf life. So don't go through your systems in alphabetical order. Prioritize systems based on the shelf life of the data that gets created in those systems, and fix these asymmetric encryption vulnerabilities, quantum vulnerabilities for the longest lived data first. That would be like the number one recommendation. And if you do that, that's something that you cannot go wrong with it. Second is, today there are already standard encryption algorithms, encryption schemes that are quantum safe, that are believed to be quantum safe. So if your system supports it, go hybrid, extend the pilot use cases that are probably already running somewhere, and do a large-scale rollout there. Topic number 3, fix crypto agility, because in our experience, this is a real multiplier, because frequency of changes for these crypto algorithms will be much more higher in the future. And maybe you can take the next 2.
Okay. So when we are talking about different things that are coming into this quantum safe world, we usually get questions about symmetric cryptography. And we maybe have mentioned that already, but usually that's quite safe so far.
Yes.
But nobody says that it cannot change within the next couple of years. So it's great to just confirm the key sizes and move on for the time being. And also, you need to close the blind spots. So there is always, a set of other repositories, some old applications, or some other things like network encryption, some devices that were clouds, for example. Yes. So it's not just about, of course, it's not just about source code. It's about much more than that. It's the picture is much larger. It's great to assess that as well, but we feel that the code assessment is the great first step. So that's the smart first step you can do.
Yes, but organizations in general should have a complete cryptographic landscape of their own environment at hand, so to know where those cryptographic assets lies and where the risks, either from quantum or classical computers, lie. So that's kind of like what we would say is 5 steps that we recommend based on the report that you see here. And in terms of putting this assessment into a much broader picture, so where does this put your organization? So we believe and we see that organizations are usually somewhere on this path from a stage of being unaware of where their cryptography, where their risks are. There is nobody owning those risks within the organization, to the advanced organizations that are already on their migration plan. They have identified all the risks, they have defined the roadmaps, they have defined the budget, and they're already having some quantum safe implementations running in production. Most of organizations are already somewhere in the middle. And what we are targeting with this assessment is we want to put you in a position that you know your cryptographic landscape, so that you are in, you know where the risks are, and you have all the information needed prioritized, so that you can put forward a plan to start defining a roadmap and assigning budgets, kicking off projects, either internal or with your vendors, to actually take the steps in order to mitigate those quantum safe risks. Because it's not only about the code that you have in your organization. So if you are an organization that is procuring off-the-shelf software, ask your vendors what are they doing about that software becoming quantum safe, what are the steps, what are their roadmaps, what are their plans, and also incorporate this into your own risk strategy. So if we want to highlight 3 things that you should take away from this session, first one is that this harvest now, decrypt later attack is a real threat. This is not some future problem. This is not a problem for tomorrow. This is something that needs to start. We need to start thinking about this right now, because the clock is already ticking. The second thing is that the scan can tell you what to fix, but it is important to interpret those scans by someone who has experience, real life experience building those systems, so that you can identify the most important stuff first, so that you do not waste your effort and you actually tackle the important things first. And in order to do that, the third thing that we want to highlight is that the assessment is the first step, because you cannot know where you need to go if you do not know where you are today. So we want to draw a map with this assessment to put your organization on that map so that you exactly know where your risks are, what are the assets that you have to manage, and what are the actions that you need to make in order to manage those risks properly. Igor, do you have something to add maybe here?
Yeah, so there is also there are guidelines from various different countries basically, and EU has its own guidelines of how to become quantum safe. US has their own, Australia has their own, and what we have seen is that there are expectations to basically make the assessment as soon as you can, and then have a good stable basis for the next steps, for the changes you need to take, for the new, for acquiring the new software products maybe, for the different configuration of your systems. So this thing, I'm talking about this assessment in its entirety, is basically a great first step. So it's relatively quick to do. It gives you useful information, and it makes next steps much more obvious, and you are able to plan and move on.
And yeah, while you are talking about this like regulatory frameworks and stuff, one thing I have to comment is that, you know, usually it's the case when you have some regulation that it gets like prolonged, pushed back in time because either the regulatory framework or the maturity of industry or something is not ready. With this quantum safe initiatives, what's interesting, you know, is that I saw that most of the governments, most of the regulatory bodies are actually bringing the date to become quantum safe forward, not pushing it forward but in the future they are bringing it back. So, for example, United States had a initial deadline of 2035. Now they pushed this into 2030. So they pulled it back for 5 years. So this is obviously a signal that the whole industry should wake up, and we should start drawing up those risk assessment maps and cryptographic landscapes so that we know where we are and what we need to do.
Okay, so let's wrap up. I think we said whatever we had in our plan, on our schedule to say. So basically, the idea is to run these scoped assessments and walk you through your own version of the report you just saw. The reports are tailor-made for your convenience, what you need most, and that's important.
Yeah. So if this sounded, as I said, as Igor said, sounded like your organization, you're running critical systems, you're running long-lived systems, or the data you have has to stay secret for multiple decades, this is exactly the conversations we'd like to have with you. If this is interesting, head out to Cross Contact Forum. The link is in the description below and also on the slide. Drop us a message on social media networks, and let's talk.
Yeah.
Thank you for your attention.